Thank you for joining us. It's now my honor and privilege to introduce our next speaker, Argonne Laboratory Director, Paul Kearns. Paul has served as lab director since 2017, and during that time, he has set the laboratory's strategic vision to deliver pivotal discoveries, pioneering leadership, and powerful scientific tools and facilities. We are delighted to have him here this evening to kick off our program. And so if you would, please join me in welcoming our lab director, Paul Kearns. Thank you.
Well, thank you so much, Robyn. It's really special to be here this evening and to see so many, and I know that many more have joined us online, so really fantastic. I am very excited about this evening and excited to see all of you here at the laboratory for the OutLoud lecture series. For those that may be new to this event, each OutLoud lecture is inspired by the innovative work of Argonne researchers and led by them. In conversation before we sat down, a visitor commented that Argonne is a magical place. And so I hope you realize a bit of that this evening and really appreciate the conversation you'll be having with our researchers here at the laboratories. But these events are designed to bring everyone into the conversation in ways that make science accessible and engaging. Argonne researchers will facilitate tonight's conversation discussing how artificial intelligence is helping us design a power grid that is smarter, more resilient, and more reliable. A stronger electric grid means more than just keeping the lights on. It is central to our quality of life, ensuring that energy is affordable and dependable, powering our communities and daily lives, and enabling the technologies that drive progress, including AI. At Argonne, AI is pushing the boundaries of discovery, accelerating experiments, guiding new breakthroughs, and analyzing complex information at speeds that no human team can tackle alone. In summary, here's how it all connects. The grid provides the power that fuels AI's ability to transform science, technology, and society. In turn, AI is helping us design a better grid to meet the energy demands of today and tomorrow. And that's the true win-win. The grid energizes AI, and AI empowers the grid. In a few moments, our remarkable researchers will give us a glimpse into their world while discussing their findings. Joining us are Sibendu, Director of the Advanced Propulsion and Power Department, and Sibendu leads the AI initiative for our Advanced Energy Technologies Directorate. He will serve as the moderator and will lead our panel discussion and the question and answer section segment that we're looking forward to. Henry Huang, Argonne Distinguished Fellow, Director of the Energy Systems and Infrastructure Assessment Division, and Interim Director of our Electricity Grid Program. He oversees research advancing a robust and secure electric grid, and Kibaek Kim, a computational mathematician in the Mathematics and Computer Science Division. He focuses on modeling and algorithms for complex energy systems. I'm also excited to share that later tonight, you'll hear from a member of Exelon's leadership team who is visiting from Washington, D.C. Exelon is the parent company of our local utility, ComEd. Argonne and ComEd have a longstanding research partnership, including a grid project that involves one of our OutLoud performers. I'm happy to welcome Haibin Sun, Exelon's Director of Transmission Analysis. Argonne has a long history of driving innovation in artificial intelligence, and we continue to be leaders in the field. We do this by combining our multidisciplinary expertise, world-class supercomputing, and strong collaborations with academic and industry partners. We're home to one of the fastest supercomputers in the world, Aurora, which is just steps from this very room. Designed specifically for artificial intelligence, Aurora is capable of making complex calculations at lightning speed for modeling the behavior of advanced materials and energy systems, to unlocking new insights into genomics and medical research. That same power is helping our scientists accelerate progress in areas such as pharmaceutical design, chemistry, cancer research. AI is really helping us to shorten research cycles and move discoveries much faster than ever before. The electric grid remains essential to Americans' economic viability and the foundation of daily life. However, our grid was not originally designed to support the immense demands of artificial intelligence and the growing digital age, while also powering our homes and critical infrastructure. Improving grid reliability and adaptability is a challenge that Argonne, working together with partners like Exelon and ComEd, is actively addressing. By leveraging advanced modeling, data analytics, artificial intelligence, and innovative technologies, we are modernizing the grid to be stronger, smarter, and more secure. We greatly appreciate Sibendu, Henry, Kibaek for sharing the impactful work with us tonight. As you listen to our researchers, know they are working with your local utilities to keep us up on the cutting edge of technology while propelling us into the future and helping us to keep the lights on for all of us. And think about any questions that you might have because we want you to engage with us during our question and answer session. You'll have the opportunity to ask questions, so please take the opportunity and really have a very engaging discussion with our team that's presenting this evening. I'm happy that you've dedicated this hour to being here with us here at the Argonne OutLoud lecture series. We do hope you enjoy your time here. You learn a few things and really enjoy the evening. So now please join me in welcoming Sibendu Sam, tonight's moderator. Sibendu.
Thank you, Paul. Well, good evening, everyone, and thank you, Paul, for that very kind introduction. Welcome, everyone. Paul already talked about the fantastic work that the lab is doing in the leading edge of AI and using AI for science applications. Today, we are going to focus more on how the AI is empowering the grid and how the grid, in turn, is energizing the AI. I'll introduce some of the key concepts, and then I'll invite my colleagues who are experts in this topic to take a deeper dive with you. So what's driving the demands for AI? Well, it's all of us, right? As we speak today, you're probably using your smartphones, ChatGPT, and fact-checking us, right? So collecting a lot of data, right? We have smart homes, smart devices. We do a lot of experiments. All of this generates a lot of data, and all of this data needs to be processed. And these data sets are processed in these data centers. AI is really data hungry. The more data that you provide, it can go through the data sets, it can learn the patterns in these data sets and develop models that can be used by us. The other thing that has happened is graphic processor units. These very powerful GPUs have come online, and these GPUs can take large language models like ChatGPT, neural networks, and things like that, and process data that would otherwise take years. These can now be processed in months and weeks, right? So these data sets are now available. With the availability of the data sets and these data centers coming online, of course, we need more power. So the electricity demand is increasing, and we'll talk a little bit more about that. And of course, these data centers are generating a lot of heat. These equipment needs to be cooled. So cooling is also a key concept here that we need to think about. So the global demand for data center is skyrocketing. We have many estimates. I'm going to provide you with some conservative estimates that basically say that the power demand is going to increase by 165% from 2023 to 2030. And then if you ask me, well, what's the AI part of that, right? So from 2023 to 2027, the AI part of power consumption is basically going to double. And then by 2030, the projections by Goldman Sachs are that globally, we would need 84 gigawatt of electricity power, okay? That's a big, big number. And you may be thinking, what's 84 gigawatts? Well, let me explain you what's 1 gigawatt, right? 1 gigawatt can actually power a small city, okay? One data center can power 1 million homes with 2.5 million people. Google estimates that an average data center requires 1.5 million gallons of water. We all take showers. A typical shower takes 10 gallons of water, Okay, so you can see the demand for industrial water is also increasing. So is our grid ready? Well, we need an all hands on deck kind of an approach here, right? We need to do many things for our grid to be ready. Our grid represents an aging infrastructure. It was really not developed for this kind of load, right? And then we need to add new energy sources. It could be nuclear, it could be renewables that need to be added to the grid. And we need to have huge investments. Again, there are projections that we probably need to have anywhere in the order of $720 billion invested in this area. And again, this is already happening. The big tech giants like Google, NVIDIA, Meta are already pouring in a lot of funding into this area. The other thing that's quite interesting is the load itself, the grid load itself, right? During the daytime, maybe there is more usage. During the evening time, maybe there is less usage. The same could be true about data centers, right? So then the question becomes, can we actually use AI to manage the load? Can we use AI to manage the grid and make the grid more resilient? So you'll hear more from our researchers on these topics. Finally, I wanted to end by saying, hey, what's happening in our backyard? Well, a lot of things are happening in our own backyard. WBEZ says that there are already 154 data centers in our own backyard, and with promises of so many more coming online, as you can see in the map. This northern Illinois region is actually very rich for having data centers because of some of the tax breaks that the state of Illinois offers, and also, we have the Lake Michigan, so maybe you can use some of that water for cooling purposes. Okay, so with that, it's my real honor to invite our next speaker, Dr. Henry Huang. Henry leads our electricity grid program here at Argonne. He's the director of our Energy Systems and Infrastructure Assessment Division. He has had a storied career, with his expertise landing him the opportunity to serve as a policy advisor for US Department of Energy, leading initiatives surrounding grid modernization. He's an Argonne Distinguished Fellow with more than 220 peer-reviewed publications. And here is to talk about how AI helps the grid and how grid helps the AI. Please welcome Dr. Henry Huang.
Thank you, Sibendu. Good evening. Excellent, excellent. How many of you have used AI today? Perfect, me too. How many of you used electricity today? Woohoo! Sorry, that's not a tricky question. It's a reminder how electricity is so deep in our society. And also, as we pioneers appreciate the recognition. So thank you all, thank you. So I see a lot of, almost all hands raised. I assume same numbers or similar numbers for online participants. It's great to see you already know the two things, AI and the grid. So what I would do tonight is just add a little bit of reflection on how these two things intersect. That's the intersection I've worked on since my PhD time, 30 plus years ago. The point is, AI for the grid is not new, but evolving. Back 30 years ago, I was using AI to study power grid problems, but the models were not very good. So what's different today? Two things: more data and better computers, like the Aurora computer Paul mentioned earlier. And those things made AI better. Now, in the meantime, the grid has evolved tremendously over 3 decades. First of all, the grid is no longer just a one-way electricity flow from large power plants to big transformers to the massive power network, eventually reach your home outlets, right? The homes, houses, your EVs, and many other consumers that could feed electricity back into the grid now and more so in the future. And that made the grid even more complex. Even the grid already considered as the most complex machine human beings ever made. So with that said, we need AI to really tackle this complexity. Second, on data, as Sibendu mentioned, we have more data in general. For grid, let me tell you this. We used to measure the grid once every 4 seconds. Imagine driving a car with the eyes open only once every 4 seconds. Unless you drive really slow or the roads are really wide. However, the grid dynamics is much faster. And then also the grid margin is become much narrower. So we need the high-speed measurements. So out of decades of innovation, including a little bit of work I was part of, very fortunate. So now we can measure the grid hundreds, even thousands of times per second. As a result, we have hundreds of times more data we can use from the grid. However, now your eyes can blink in faster, but your brain cannot catch up. We need the AI for the grid. So AI holds the promise to understand the grid capacity, to process bigger grid data, and eventually help the grid to sense, decide, and act in real time. It's great, bright future. But all this doesn't come with no cost. As Sibendu mentioned, training AI models require big computers. When the data centers get bigger, they consume a lot more electricity, hundreds of megawatts to gigawatts. You may wonder, where does the electricity go in the computers? Some of you have your laptop with you. Imagine this, when your laptop gets hot, right? That's exactly what happens. Electricity powers the chips and turns into heat. Scale this up to the big data centers. The heat becomes so massive. We need a lot of water to cool. Sibendu mentioned the millions of gallons of water every day, and that consumes 40% of electricity in the data center. So this is truly an AI power and the water nexus and a challenge. Putting data center up is not just simply putting a demand on the grid. We will have to design AI powered water systems together, not in isolation. We need to know where the power is, where the water is, and then how the data centers would match the power and the water resources, right? And also we need to figure out how can we design more efficient data centers? How can we have a new cooling technologies? How can we make the data centers be flexible, be a friend to the power grid? So that is really require public-private partnership, engaging everybody in this challenge, the utilities, data center owners, and policymakers. Now back to Argonne. We already applied AI to a lot of the applications in the grid. What we see is AI is really a powerful optimization tool which touch the whole grid system. So this is a list, only partial list, what we have been working on. Let me highlight a couple of things. So we already have optimization tool can run 100 times faster. We have a large language model can help utilities to assess the impact and risk of extreme weather conditions. Like in Chicago, we also get tornadoes. I already got a few tornado warnings, even I've only been here for a year. We moved here last summer. Fortunately, we haven't no power outage yet. But we also have a tool, we can use AI to manage the health of the equipment. It can reduce the failure by 60% and cut the cost by 40%. By the way, this tool just won R&D 100 medal. We're very proud of it. And then we also apply AI to forecasting the demand, so we can manage that ahead of time. Also use AI to handle cybersecurity, so we can contain the cyber issues at the edge, not propagating to the upper level system. So lots of good work going on at Argonne and also other places. What I would say is this, I'm very confident AI will be better and the grid will be better. The key is we want the power intelligence by intelligently powering it, right? And again, I'm so glad to see this high level of interest tonight. Our goal is to see AI can make the grid better, and the grid can make AI possible. So let's work together, build both together, stronger, smarter, more resilient for our energy future. Thank you.
Thank you very much, Henry. That was fantastic. Now we turn to my colleague, Dr. Kibaek Kim. He's a computational mathematician with a PhD in industrial engineering and management sciences. He has received a number of awards throughout his career, with his research focusing primarily on computational optimization. He is currently collaborating with ComEd on a research project that uses AI to watch anomalies in the grid. And here is to give us some specific case models on how AI is used on grid operations. Please join me in welcoming Dr. Kibaek Kim.
Thank you, Sibendu. Okay. Hi, everyone. My name is Kibaek Kim. I'm a computational mathematician at Argonne. I'm actually working across different areas where AI and algorithms can really make an impact, whether that's helping with scientific discoveries or tackling computational challenges. Today, I will focus on one area that touches all of us, the electric grid. I will share how AI can help us run the grid more reliably, more efficiently, and respond faster when challenges come up. So the grid is becoming smarter every day. We now have sensors across the system and more real-time information than ever before. That gives us an incredible opportunity, but it's also a lot for people to sort through on their own. AI helps by turning all that information into early warnings and clear, simple suggestions for operators. The benefits are wide-ranging: fewer outages, steadier bills, faster restorations when something goes wrong. And those are just a few examples of what's possible. We just saw why AI matters now. So how does that actually work in practice? Let me walk you through this workflow from left to right. We start with C, combining weather data, sensor readings, and maps into one clear view. Next is predict. The AI forecasts near-term risks like outages, equipment stress, or sudden demand spikes. Then comes recommend. It creates a ranked to-do list with short, clear reasons behind each suggestion. And finally, explain. Operators stay in the loop, reviewing every recommendation, while everything is logged so the system can keep evolving, learning, improving over time. One of the most important parts of this workflow is speed. That's actually where AI really shines, running complex simulation much faster than ever before. Let's take a look at how AI accelerates simulations. Traditionally, running thousands of what-if studies could take hours or even days or years. With AI, those same scenarios can be explored in minutes or even in seconds. On the left, you see a Texas grid. Here, AI achieves simulations 1,000 times faster than current computational method. On the right, you see an even larger, bigger case, the US Eastern Interconnect, where AI makes it possible to study problems that were once far too big to handle in real time. The point is, operators can now get actionable insights much faster. And when we are facing real-time risks and emergencies, that speed isn't just helpful, it's essential. Now imagine pairing that speed with reasoning support. That's what we mean by an AI copilot. It helps operators understand complex grid conditions, run thousands of scenarios in the background, and then distill the results into ranked, explainable recommendations. On the right, you see a high-level illustration of how this would look like in practice, a dialogue between an operator and the AI. So in fact, actually, the app operator in the chat asks a question, and the AI works through the steps, like you're using ChatGPT. Then understanding the task, AI will understanding the task, running the analysis, validating the results, and then summarizing the findings. The important part is actually that operators stays in control. But with this copilot, they can make faster, more confident decisions right in the control room. So far, we have looked at how AI can support operators with fast simulations and co-piloting in the control room. But AI isn't just a future vision. It's already being developed and tested today. One example is our ongoing collaboration with Comet on smart meter anomaly detection. Millions of smart meters across the system record voltage and usage signals. By pulling that in large data into one big AI model, we're able to identify unusual patterns much earlier than traditional methods. The project is still in progress, but the early results already show how AI can help catch issues like transformer faults or abnormal usage before they grow into larger problems. This work demonstrates the practical path from research from real-world application, improving reliability for customers and reducing cost once deployed. All of these points toward the control room of the future, a place where operators and AI work side by side. AI brings speed, reasoning, and predictive power, while operators bring their expertise and judgment. Together, they can make faster, better informed decisions. The goal is not to replace people, but to give them stronger tools to keep the grids safer, more reliable, and more resilient. When the grid empowers AI, AI empowers the grid. We unlock a smarter, safer, and more resilient energy future. Thank you.
Well, thank you very much, Kibaek. Thank you for giving some specific examples on how AI is improving the power grid. All right, now we are really privileged. We have someone who is our own guest joining us all the way from Washington, D.C. is Director for Transmission Analysis at Exelon, Dr. Haibin Sun. Exelon Corporation is the nation's largest regulated electric utility, serving more than 10 million customers. Exelon is also the parent company of our regional power distributor, Comet. It's important to point out that Argonne and Exelon have a partnership that has lasted nearly a decade, and with projects that have bolstered grid resiliency, reduced cost for energy for consumers, and enhanced energy resource management. Part of the partnership includes collaborations between Argonne and Comet, and you just heard Kibaek share some of the research he's currently working on this topic. Here is to discuss how AI is impacting the electric grid and the challenges power companies are facing. Please join me in welcoming Haibin.
Right. Thank you. Good evening. Thank you for the introduction, Sibendu. My name is Haibin Sang. I work for Exelon. I'm on the transmission planning side, so my comments tonight were mainly from grid planning perspectives. I can really relate to what the speakers earlier talk about AI application, because that's kind of our day-on-day job. So for me, I didn't prepare slides, but I want to use a few minutes to touch on probably mainly 4 points. First one is about the impact of AI infrastructure to the grid, which is what we work on. The second one is for the company that I work for, Exelon and Comet, in this case in Chicago area, what we have done to facilitate the development of AI, and also what we have done to help deal with some of the potential challenges to the grid. The third area is I want to touch on some of the upcoming challenges to both the AI or tech industry as well as to us, the utility companies. And lastly, I want to kind of refer to a few use cases as what I can see. So first one about the impact of AI infrastructure to the grid. We heard not, right? AI infrastructure, or if I refer them to data centers, they consume a lot of energy. So in the industry, there is this big concern about this upcoming huge surge of electricity demand. And then this is, this is kind of calling for, unprecedented strain on the existing grid. So, I want to put it out there up front, I want to put that in context. Sibendu made some references about what does it mean in terms of size of a data center. So these days, a typical data center, they might be what we call 50 megawatt. So I know, sorry, this is a little bit jargon, but let me try to translate that to you. 50 megawatt roughly equates to 40,000 average household energy consumption. And then what's more interesting is the industry is talking about the data center going up to 1,000 megawatt or even bigger. So that equates to 600,000 or more average household energy consumption from that lens. So that's certainly a huge challenge, right? And then think about what the Department of Energy and what we call NERC, the North American Electric Reliability Corporation, which is based on the regulatory authority for grid reliability and security. They have done their research and studies. They both called out the concern, this huge concern of reliability may come down if we don't do something to address this challenge. They call out for huge generation investment as well as grid infrastructure upgrades. So in addition to AI, I also want to recognize there are a few other things which is happening. Okay, so they're both on the generation side, on the supply side. So a lot of generation resources are unfortunately retiring, given the plant economics or the environmental policies. Also, the pace of adding new generation is not as high as what we may expect. And technology is different. You have solar and wind come in. They don't have the same characteristics as the traditional, what we call firm and dispatchable generation, when you can generate whenever you want. And then one thing I do want to mention is for Comet, in this case, we are a transmission owner and we are an electric distribution company. We have the responsibility to serve all the node from small to big and everything in between. It's obligation we cannot say no to. All right, so the second point is about what we have done to facilitate the AI in development. So Illinois as a state has a very strong incentive for economic development. For our company, we want to support the state's priority And then, so that's why we have, done a lot to facilitate the AI, interconnection process. In the same time, we do recognize, there will be a lot of potential stress to the grid, so we are doing a very rigorous engineering studies to look at the potential implication of the data center to the grid. We use a lot of data, use a lot of models, we actually need the support of AI to help us run those models to make sure, the grid will be safe, reliable, and we can deliver that affordable energy to everybody. All right, I'll be real quick, and I know my time is coming up, but plan to elaborate later on. About the third point, in terms of the upcoming challenges. So sheer size of AI is huge, and for both AI developers and utility companies, we see this challenge from supply chain. And also, the cost implication, the timeline implication, nothing can happen as fast as what we expect. Second one is we do need a lot of data, from AI developers for us to evaluate their potential implication to the grid. But unfortunately, they all have their own business model. This is their own, competitive edge. They have to keep a lot of those close to their chest. So there's this process, that we need to develop to build that trust and build the transparent enough process to enable us to do the study, and which will come back, kind of ensuring the grid reliability for the, broader customer base. Lastly, just briefly touch on some use case. Kibaek, touched on a good amount of those. I would say there are some low-hanging fruit in terms of data management, in knowledge management, training our employees, or using AI to help with our asset management. We have a lot of sensors out there to help detect the material condition of our equipment. There's something which requires more work. Like with the grid is getting more complicated. We are deploying a lot of sensors, throughout the whole grid. Nobody has the capability of monitoring all of them. So we're going to leverage AI to help with the operations and also coming back to the planning side of the grid. Right, I'll pause here. Thank you for your attention.
Thank you, Haibin. All right, thank you very much, Haibin. Thank you for echoing some of the things that we said earlier and some of the challenges that the electric companies are facing. So now I'd like to take this opportunity and invite all the panelists on stage, please. Good job. Please. And we prepared some questions that we thought would be in everyone's mind. Okay, so we'll start off that way. And then, of course, we'll have an opportunity where we'll invite everyone to ask questions as well. So the first question is always about AI, and can we trust AI, right? So can we trust AI on our grid?
Well, I spoke about the implication of AI to the grid, right? This is, and we all recognize this is a huge challenge. Of course, we need to look for solutions. So as a company, we're leveraging our partnership with parties like Argonne and the others, kind of look for those. And also within the industry, we're working closely with our peers as well as AI companies themselves, to figure out what are all the solutions that we can think of. I mentioned, largely, if you think about AI represents a huge electricity demand, which is on the supply side. And I spoke about the supply side, seems to be outpacing what we expect to see on the, demand side seems to outpacing what we see on the demands, on the supply side. So we need to figure out a way of, kind of increase this. And then the other thing I do want to mention is in addition to kind of catch up on the generation resources to match the demand, there are some more advanced approach that we are exploring with the industry, basically on the operation side, to look for certain flexibilities When the system is most stressed, we probably need to figure out a way to relieve that stress and shift that electricity need, to a different time, when the system is better prepared to serve this kind of node.
Anything else anyone else wants to add?
Maybe 2 quick points. I would say we want to trust AI. That's why we all use it, right? But I think it's key to see how the AI models been developed. As like any models, the input is important. That's why if you just use general AI to answer the question you want, is very specialized, the answer may be different than what you would expect. That's why at Argonne, we actually built our own AI model, Argo, right? So it's really for scientific purposes. So I think that's the one thing I want to say. And second, say, you need to be fair to AI. How to compare artificial intelligence versus human intelligence? Humans make mistakes as well. We're all making mistakes, right? So how can we really put the 2 things on the equal footing and so compare them? That's a question. So we want you to think about that.
Yeah. Thank you. So maybe another question, right? I live in Naperville. My electricity cost has gone up this summer. ComEd warned me that this was going to happen. So maybe a question for my panelists here. Is this because of AI?
That's off the script. That's not on the script.
I was told this is very friendly audience, Yeah. So I think I put it up there, up front. AI represents, from electricity perspective, represents more node. And more node means there's going to be a tighter supply-demand relationship. And yes, I think AI is contributing to the rise of energy cost. Speaking, when I say energy, I'm referring to the actual energies in electrons that we are that's actually flowing kind of to power our equipment, but also there are other components of your energy bill. A good part of that refers to capacity price. So in terms of how big impact that is, it's really difficult to quantify in terms of does it make 20%, 30%. But I have some data. If I recall correctly, like EPRI, they did some research, for the state of Illinois. In the next 5 years or so, they're expecting AI load to account for more than 5% of overall energy consumption in this state. For some of the other states, there's one extreme case, Virginia. They quote out it's going to be more than 20%. The reason is that Virginia happens to be this, capital of AI. They're not of large-scale AI or data center projects have already been established there. And Illinois is not unknown. There are many other states that energy consumption being driven by AI will be in the range of 10 to 15%-ish, as predicted by EPRI, like Iowa, like Wyoming, Nebraska, those kind of states too. So I think this is something that we are expecting. So and then we recognize. But I do want to go back to the point of a lot of things that's happening in the market is a input to ComEd. When it comes to ComEd, generates everyone's bill. We are on the receiving end because there is this brilliant idea of the whole industry coming up with the electricity market and rely on the market efficiency to come up with the most effective way to supply to meet the demand. And then for ComEd as a transmission and distribution company, we are on the receiving end of those, and we have to pass the cost to our customers. Recognizing the stress, ComEd have been doing a lot of work, in terms of helping all our customers, especially customers in need, to deal with the challenges. There's a website, my colleague, Maisha told me that it's ComEd.com. and bill support, there are a huge number of programs that Comet is administering that will support our customers. The total budget behind it, as what I heard, is more than $130 million last year. And this year, we are actually adding another, relief fund, which is kind of released back in July, $10 million to help our customers to deal with it.
Thank you very much, and thank you for everything that Comet and Exelon are doing. That really helps. So now we move, now that you have got a flavor of the questions, right, it's your opportunity to ask questions. So if you have a question, please line up there behind the microphone. Please use the microphone, ask your question. And if you're online, we can still accommodate you. Please type in your question in the chat window. Please go ahead, sir.
Good evening, and thank you so much for doing this. I think one of the most important parts of AI is getting the community involved. What I've heard so far tonight is a pretty industrial era conversation. And what Tom Friedman showed us a couple of weeks ago is a great epic change from like water to steam. We are about to go into an era that is so different than we know. And part of that is driven by the data. And Comet is generating tremendous amounts of data. Every industry is developing tremendous amounts of data. And we don't own it. And I'm so excited about AI, and I'm so scared about AI because of this dual risk-reward situation. Can you describe the top 1 or 2 political challenges that we have to go forward in this world?
I can take a shot on that, and then Haibin, please add. Tough question, by the way. So I think one thing we need to think about is AI governance. Think about, as you said, this is really a revolutionary time, right? Think about nuclear power, right? So the technology is nuclear technology. It can be used in different ways. Now, if you use it for nuclear power, benefiting the society, great. So that was a time in how we need to manage nuclear technologies. So today, we're kind of similar situation, how we manage AI technologies so they can serve us, not hurt us. So AI governance becomes such a big issue, and then a lot of countries already putting rules together. It's really the two ends of story. One is the risk, and one is innovation. And then how you balance that. If you want to pro-innovation, maybe it's more risk. If you want to control the risk, then you control the innovation. So I think that's really the balance. Many countries are trying to figure out how can we move forward, but in the meantime, have a guardrail of the technology. So I think that's one of the things really need to be in place.
Right. Thank you for the question. Try to be brief here. I think from the AI application or use case perspective, I agree with Henry. AI governance is one of the big problems out there, especially for the power industry, because we have a lot of what we call the critical information that we have to protect. When we use AI, we need to come up with the right guardrail around it. When it comes to supporting the AI development, I'll briefly mention a couple of things. The first one is as we see this tremendous stress that AI is bringing to the grid, which seems to be having a burden shared by everybody. We need to figure out a way from a political perspective how to shift the burden a bit more back to the AI development industry to say, hey, what can you do to help address the resource adequacy issue and help with the grid reliability? The second one is dollars, the cost. So when it comes to bringing more resources, either generation or a grid facility, there will be cost. So we are very actively working on how to figure out a way to have the right party to take a bigger share of the cost allocation. And one thing I do want to mention is Comet has done a great job in kind of founding this what we call large node tariff with the Illinois Commerce Commission. basically it's kind of to increase the financial responsibility of AI developers to make sure they're less speculative and they are taking more of a share of the cost implication.
I can make one more quick connection to your question. Thanks for the question again. So I think it is healthier to think about a little bit or have a little bit of a skepticism of using AI and also use the AI with concern. In fact, one of my research areas is quite relevant to that skepticism and conservatism because when it comes to AI, we are using a lot of data, and data can come from anywhere from, including you and our families and anywhere. And that data can concern you about privacy. That one of the research that concern actually works as a feedback loop to the science community to develop new algorithms and techniques to protect the privacy. So in that, as part of the effort, Argonne is actually working on developing, protecting privacies and training the model without using the privacy data, the private data and proprietary data. And so I think that this dual use of using AI actually can advance at the both angles.
All right, we have a question from online. Can you discuss quickly using electric battery storage for grid stability to meet those data center power demands?
Yes, absolutely. I think storage is an important piece of the puzzle. So data centers, by the way, just in case you don't know, depends on how you run the algorithms on a computer. The data centers does not consume power constantly at a certain level. It could fluctuate, right? So the fluctuation is not something good for the grid. As a power engineer, we don't like that. We like everybody listen to the grid, just be stable, then we are happy with that. The things cannot be predicted, we don't like. So data centers not become like that, right? So if you fluctuate, that's going to cause trouble to the grid because then we have to balance the generation to match the fluctuation. Remember, the reason why is that case because there's no big buffer, no big storage in the grid to say you can produce more at this time, but store for the future, not yet at that stage. That's why storage, it can be a really important piece. If it can be more widely applied, they have a bigger buffer, then your data center can become a steady load to the grid. That's better for the overall grid stability. So I guess the answer is yes, it's an important piece.
Yeah, I want to echo that. From a few perspectives, battery can become a source, the energy source to load, including to AI infrastructure or data center in this case. But I do want to mention, want to provide context again, 1 megawatt of a storage, battery storage, we're talking about half of a semi-truck. That's a relative size. If you think about these days, the data center, 500 megawatt or even up to 1,000 megawatt, just imagine how much battery do we need there. Second one is, I mentioned earlier about the retirement of a generation and the new generation resources. None of those are solar and wind. Solar and wind, you cannot control when they will generate. So, it fluctuates with when sun is out, when wind is strong. And then battery can be a good resource to help store the electricity generated by solar and wind and discharge to the grid when it's needed. So that's very important to the stability of the grid as well. And then when it comes to looking for solutions, I would say we have to leverage a lot more options to solve the problem that we have. Energy storage or battery storage unknown. It's very helpful, but it's not going to be enough. So it does not replace the other options that we need to explore in terms of adding more generation, having grid infrastructure upgrade, and potentially looking for more demand side of the options as well.
Thank you. We want to be respectful of everyone's time. Maybe we'll take one last question, please.
Great. We are actually going to extend to 7:15.
Okay,
Just so the
okay.
panel knows.
All right, thank you.
Excellent. Thank you so much for sharing your insights with us this evening. Another question, double clicking on cost. Really interested, having just learned that by 2030, we'll have 165% increase in demand of the most complex machine that humans have ever built. I guess this is a question to all three of you and a bit of speculation required, so my apologies in advance. As the consumers, as public-private industry partners, and as the providers, what do we think the split is going to be, say, by 2030, in which entities will bear the burden of this generational investment that's required to get us there?
I can see something about from the research perspective. So I think the cost is a very complex issue. So there's a study in how we can do cost allocation. So we all know it's already happening. So the rates went up in our region, right? Now, Haibin explained really well what happened, what caused it, right? I think the question is about the future, how can we manage this, and then who should bear the cost? That's a conversation involve a lot of stakeholders. If you're looking back, right, so when there's a new technology coming up, the demand went up. So it's a simple equation about supply-demand balance, right? So that drives the cost. Now, in this case, who should bear the cost depends on how each party in the discussion feel there's a benefit. That's one basic thing. And then really, how can we look into the future? This is going to be benefiting not just one particular group. This is revolution, as another gentleman mentioned, right? So we need to develop this technology and then make the future generations, to benefit from it. So I guess it's a conversation going on right now. There's a lot of discussion in different regions and how to allocate the cost. I think maybe Haibin can chime in and say, what's the current status of the conversation and where this might be going.
I count on you guys to train the AI to help me answer the question. I'd like to be transparent up front. I don't have the answer of this, but what I can say is cost is one of the top priorities on our mind when it comes to us working on any projects. And these days, I would say supporting the large node, including AI infrastructure, takes a lot of our time. Speaking for my company, end of day, there are two main paths in front of us. One is market-based, the other one is a regulatory approach. When it comes to cost, as I think about it, I'm an engineer by training. I did work on market, energy market for majority of my career. So if I'm kind of going a bit of off script, just offering my thoughts. So there will be cost coming from energy. There will be cost coming from how do you fund the incremental investment for generation assets as well as for grid assets. So largely speaking, when it comes to generation assets and consequently the energy price impact, this has been, to a large extent, rely on the market, how the market functions. And then as I share my own personal view, I think when it comes to energy, it's very difficult to differentiate, this is the energy coming from a residential home versus, energy need coming from, a data center node. Although the market will try to come up with what we call the locational price differences. So that helps a little bit. But the reality, as what I expect to see, is that everyone will need to share the burden. The energy price will increase. On the grid infrastructure side, so that's where there will be this approach that we need to work very closely with our federal and state, policymakers, regulators to figure out a way to have the beneficiaries to pay a bigger share. I don't have a formula in front of me, so I don't think anyone has a formula at this point. So what I can say is that as a company, we're committed to stick with that philosophy to protect our customers to the extent we can. Realistically speaking, I do expect the energy bill to, as a result of everything, will increase. But I am, again, speaking for myself, I'm expecting going forward, once all this energy consumption picks up, given the way how the broader kind of infrastructure costs are shared, if the AI accounts for a large portion of total electricity demand or consumption, they will end up sharing a significant portion of all the infrastructure investment. So that's going to be something that will come as a bright side of everything for everybody. Hopefully that answers your question. Thank you.
Simply from the research perspective, computational and mathematical research perspective is just a balance between demand and supply. Now we are seeing more demand than supply. And as Haibin mentioned, people have been working on energy planning, transmission planning, and operations. And actually, from the research perspective, we are working on new mathematical models and algorithms. AI is actually part of it to improve efficiency of operating the grid systems, and as well as to find the better planning solutions for these landscapes. So hopefully AI can help to better be utilized and improve the efficiency and reduce the price as well.
How do you guys feel about artificial superintelligence, and will AI ever gain self awareness or something?
AI aggregate, sorry.
Can AI superintelligence? Can AI exceeding
superintelligence.
Yeah.
How do you guys feel about artificial superintelligence, and will AI ever gain self-awareness?
No.
Yes, I read a lot of books my son read. Those books says that's a possibility. But then I guess the thing is how we work with that intelligence in the future, and then make sure we and the superintelligence can still be friends.
Yeah, maybe I can add a couple of things. It's an excellent question from the next generation, right? And
thank you.
We really need to think about it. So the way we talk about it internally is we need to use AI. People, researchers who use AI will replace researchers who do not use AI. AI is already powerful enough that you can do inferencing, right? You can ask your chatbot questions and it'll provide answers, it'll make images for you, right? So there is a level of inferencing that it can do. The question is, can it do reasoning, right? And that is still not clear, right? It can do reasoning to a certain extent, but AI is becoming self-aware. Your question is very pertinent. As government lab, it's also our responsibility so that we can develop appropriate guardrails so that AI is used in the way it is supposed to be used, right? So lot to unpack there. Fantastic question from the next generation.
I want to add is that I'm really happy to see you actually thinking about this. Actually, you're thinking deep about this. So that's the hope. So thank you.
I can quickly recommend one book that I really enjoyed. It's called Brief History of Intelligence. That book actually connects the intelligence between human intelligence and artificial intelligence, and how artificial intelligence has been developed based on the human intelligence and the concept of human intelligence. After reading that book, I was actually a bit skeptical about AI area. But after reading that book, I think it may be possible to advance AI techniques to the human intelligence level.
Okay, one more question from online. We have a couple questions here about heat, using heat as a byproduct. So can waste heat generated by data centers be used for supplemental power generation?
Maybe I can take that question. That's an area of research that we do some work in. And absolutely, the answer is yes. Requires a lot of thoughtful planning, integration, right? Typically, these data centers are housed in big buildings. Can we use the heat that's generated to heat the building, for example? These are active areas of research. These are areas where there's a lot of integration that needs to happen between the IT, between the building, between the infrastructure, the data center. So a lot of integration needs to happen so that the planning is appropriate, so that the heat that's generated is actually used effectively. So a lot of research going on in that area. We are also, as a DOE lab, figuring out how the DOE labs can actually help in some of this integration. There are building management tools that DOE has developed where you can understand the building loads and you can figure out the building loads based on the time of the day and things like that. And these all need to be further enhanced so that it can account for the IT loads and the heating loads that the data centers put out. So the answer is absolutely yes. It's an active area of research for us.
And also there's something in the grid area. It's going to combine heat and power. So this is exactly what it does. It's using the residual heat from power plant to heat homes. So data centers can be in the same category, right? If you have enough heat from the data centers. So I think, again, your answer is yes, but it does require technology development. How can really utilize the heat in the right way so it can be benefit to anyone, maybe the user.
Yeah, something quick I can add is, first of all, I don't have expertise in terms of a data center design itself, but I'm curious enough, reading to some of the articles and also following the development of certain large-scale data center projects. So one thing I noticed is in a more advanced data center design, they are trying to come up with a system to not waste any water. Basically, the 100% of water will be recycled, and then they are certainly, the industry is certainly making, having a lot of discussions and trying to improve the design to preserve the energy and also recycle the energies.
Hi. Thanks for contributing your time and sharing your knowledge with us. I appreciate you all being here. So I suppose my question, you kind of just addressed it. I was going to ask about water and the environmental ramifications. Basically, where is the energy / power supply coming from that's supplying the grid? You also mentioned putting data centers in Illinois as well as Wyoming and Nebraska. And when I think of those places, I think of agricultural hubs, farmland. So you were just saying that the water is recycled. My concern is that the water is being rerouted from the farmlands to supply these data centers. And then in a butterfly effect sort of way, that would impact our food supply as a nation. So could you elaborate more on the AI power water nexus sort of in that context, please? Thank you.
That's a great question. Absolutely great question. So yes, there will be impact. Just like a power, you draw power from some point, there may be some impact to the neighborhood. You draw water from somewhere, the impact to the local regions. So that's why it requires careful planning. And again, at Argonne, we have a tool can help with that. It's a geospatial energy mapper or GEM tool. It has 250 layers of information. There's a layer of information about where the power network is. There's a layer of information on where the water resources are. There's information about where the farmland, the land use. There's a geological information. There is a rock or anything, how to build anything on that. There's a lake you cannot cross, or reserves, you cannot build anything. So we have that tool we can use to help to consider all the regulations and identify the locations that most suitable for data centers and other assets as well. We use that for power line siting, use that for power plant siting and so on. So that's actually a good tool. I encourage you Google that and then maybe find some information for it. By the way, I also want to add one more thing. Even I'm a power engineer, but I would say the water challenge is pretty much bigger. In theory, you can draw a power line. The electricity may go from one place to the place you want to use the electricity. But for water, if you don't have water locally, how would you deliver water? You have to dug a river. That's huge effort then build a power line. So I think water would be a really important issue.
Thank you, gentlemen, so very much. Can we give our researchers a hand? You know, as I listened, I thought about the fact that there's so much wonderful opportunity that exists between the power of the grid and the power of AI, but it does require a great deal of care. And I really feel like our future is in great hands because of the gentlemen who are on this and the ladies as well who are contributing to this work. Thank you so very much. So we stayed a little longer than normal, but we thought we had to because we saw the questions and the enthusiasm. And so we appreciate that you stayed a few minutes later with us. You see on the screen, it says outloud@anl.gov. If a question comes up later on this evening and you want to ask the question, please send it use that email to send your question and we'll make sure to get an answer for you. So you'll see here there's a QR code before you leave. If you wouldn't mind, please just fill out, that's a QR code that will take you to a survey. And we depend on those surveys to really help to continue to hone and make this experience better and better every time that you come. So just take a moment. It's a few questions. Fill out the survey before you leave. We would really, really appreciate it. Last thing I want to mention is that if there's something you heard the researchers talk about that you're fascinated by and you want to check it out again, and I think I'm one of those people, go to the YouTube channel in about a week. And this program will be available to you to view and to also share. Please feel free to share it with everyone who you might be in your sphere of influence and who might find this interesting. With that, we bid you a fond farewell, but we look forward to seeing you in just a couple of months when we have our next Out Loud. Thank you so much for coming, and please remember to come again.